All right, so we kind of previewed this last time, the next module, which is conditionals, because we're going to have to write more complex, more sophisticated code that now needs to make decisions. Do one thing or do a different thing. Normally, programs have a sequential control flow. If you, oops, yeah, we're good. Remember that we are online, so if you have any questions, go ahead and post to Piazza or to the YouTube live stream here. But otherwise, normally programs have a sequential control flow. That is, if you've got statement A, statement B, statement C, it executes statement A, statement B, statement C, one after the other, top to bottom, left to right. But otherwise, sometimes you need to make decisions. And conditionals are how you make those decisions. Execute this piece of code or don't execute it. Execute that piece of code or execute this piece of code, one or the other, but not both, right? And you can specify how that happens using logical conditions along with if statements, if else statements, and if else if statements. They're actually all the same. It's all just one big if statement, if else statement, where some of them are empty and optional. But otherwise, conditionals rely on some sort of logical condition, right? Something that it's a Boolean statement that's either true or false. It's not somewhere in between. Right? Or it's not indefinite. It's definitely either true or false. It has to be determinable, right? In order to make that decision. So we'll start with a basic syntax here, right? And then we'll move on to actually using them in practice. With an if statement, you use, who would have thunk, the keyword if, right? And then you provide some sort of conditional inside that if statement, inside the parentheses there. Now that Langle-Wrangle conditional, right? That condition, that's not C code, right? That's a placeholder, and we'll fill that in later. But otherwise, you open up a curly bracket and close a curly bracket, and there's your code block. Anything inside that code block will execute, but only if the condition is true. This code block will execute only if the condition is true. If the condition is false, none of the code block executes, and the program continues after the block, right? So that closing curly bracket. After that closing curly bracket, it'll just continue with normal sequential control flow. So in this case, it's either it executes or it doesn't. It fully executes or it doesn't fully, none of it executes, right? You can also use an if-else statement, right? You can also use an if-else statement. And the syntax there is almost virtually identical. It's just that in the first one, we did not specify the else block. So again, I've got the if condition, or the if statement, and I've got a condition inside parentheses here. Space, opening curly bracket on the same line. And then at the same line, I've also got else, and then another opening curly bracket and another closing curly bracket. And here I've got block A and block B. Right? The explanation here is that block, if the condition is true, block A is executed, and block B is not executed. If the condition is false, it's just the opposite. Block B is executed, and block A is not executed. Right? In other words, one or the other will always be executed, but never neither nor both. Right? In other words, they are mutually exclusive. So if one executes, then the other doesn't. It excludes the other. If A executes, it excludes the possibility that B executes. If B executes, it excludes the possibility that A executes. And so they are mutually excluding each other out. It's one or the other, not both. And one or the other, it's not going to be the case that neither one of those executes. Right? Because it all goes back to the condition. A condition is either true or false. There's nowhere in between. Okay? Let's go ahead and get some practice with this. We'll talk about more sophisticated conditions here in a moment, but I'll just quickly introduce you to one. Right? I'm going to go ahead and set a variable here to be value 10. And I'm going to have an if condition, and I'm going to check if a is equal to 10. Now that's a very different than what we've seen so far, right? Up till now, we've used the single equal sign in order to assign a value. Take the value on the right-hand side and place it into the variable on the left-hand side. And that's the assignment operator. Well, if a single equal sign already has a meaning, how do we use the algebraic equal sign, right? Is this thing on the left-hand side equal to this thing on the right-hand side? And the answer is to use two equal signs here, right? Some languages, we won't get into it, but some languages have to go even further and use three equal signs because they have strict equality testing. Don't worry about that. That's not in C. Right? This is asking whether or not the value stored in A is equal to 10. And if so, it'll execute this code block, printf. It is 10. Right? There we go. End the line. End the line. Sorry, there we go. Now let's go ahead and compile this. This is just demo code, right? Now, is this going to print out it is 10 or not? Yes. Why? Because the value is 10. Right? If the value were not 10, if it were 20, right, then would it print anything out? Nope. What'll it end up printing out? Nothing at all, right? Why? Because A is not 10, so this entire code block does not get executed. Normal control flow returns to line 12, and that's the end of the program. Right? We could have an else condition here and print out something else in the event that it's not equal to 10. Printf, it is not 10. Right? Just some, dummy code. Right? Now, what's it going to print in this case? It is 10. It is not 10, excuse me. Right? And that's because it is not equal to 10. These are mutually exclusive code blocks here. Now again, note the syntax. I open the opening curly bracket on the same line as the if statement. I indent the closing curly bracket at the same indentation level as the I. Right? I have the else and then the opening curly bracket all on the same line, right? And I'm closing it down here. That's one convention that I would encourage you to follow. That's the convention that I'll follow. Other conventions, of course, could look like this, right? Right? I don't know. Do you like that a lot better? I don't personally because it spreads code out, right? This compactifies it a little bit, and that's why I prefer this more modern style. Okay? All right. So, you can also extend this. Let me give myself some more room here. There we go. Let's do this. If, else, if statements. Right. You can also add additional conditions. Right. As many as you want by adding more if statements. Right. Using else if statements, I should say. Sorry, else if. There's not really an else if keyword in C. Instead, it's just an else and then if. Else and then if. And let's go ahead and look at a generic example here. There we go. There I've got three conditions. I've got three different things that could happen, right? That requires at least two conditions. Condition 1 and then condition 2. So normally, if we just have an if condition here, if this is true, then this one will execute. Otherwise, if this is false, it'll fall through to the next condition and check that. Is that true? If it is, then it executes statement B. If it's not, then it goes and checks the next condition and the next condition. You can have as many conditions as you want with as many else-if statements as you want. And at the end, you can also have a catch-all, right? A default behavior of an else statement, just like we did with an if-else block, right? You can do as many of these things as you want. So, for example, let's come up here and define another variable here, int. In fact, I'm going to define two variables, Husker score and what are we playing, North Dakota or something? Away score. All right. Nobody knows? Nobody follows Husker football on UNO campus? Well, no, that was last week. All right, want to do Northwestern? All right, score. They were 31, right? Yep, 28. More than covering the spread, or more than beating the spread. All right, so we can check if the Husker score is less than the Northwestern score. Then what can we say about the Huskers? They lost. Printf. Huskers lose. Right? Just like they did. Right? End line. Right? Else if, now I'm going to ask a different question. What if the Husker score were greater than the Northwestern score? Husker score is greater than Northwestern. Right? Then who won? Huskers win. Right? Is there any other possibility? Okay, a tie. Do we allow ties in American football? Nope. So, what do we do when there's a tie? Go. Oh, well, the coin toss is part of it. Go to overtime. Good. There we go. All right. So now, suppose that we didn't know the outcome there. I'll go ahead and set this equal to. I don't know. They decided not to do that onside kick. All right. There we go. All right. So which one of these conditions is actually going to execute here now? The second one, right? Why? Because Husker score is strictly greater than the Northwestern score, and so we print out Huskers win. Right? Unfortunately, it didn't turn out that way, right? And so, if it's 31-28, who wins here? Or what happens? Or which one of these gets executed? Huskers lose, right? Suppose that we were able to prevent, I don't know, a field goal, right? And there was a 28-28 score. In other words, it's a tie. Where are we going now? To overtime, right? At any point, did more than one of those statements execute in any one program, run of the program? Nope. Just like an if-else condition, an if-else-if condition is completely mutually exclusive. At most, one of these things will execute, and the first one that has a true condition is the one that it gets executed. Right? So, the control flow operates as follows. Right? Each condition is checked in order. That is top to bottom. The first condition that evaluates to true will execute its code block. Right? All other code blocks will not execute. Right? Anything before that was not a true statement, anything after will not execute either. It will immediately jump to the end of the entire thing. It will return control to the end of the if-else-if block. Right? And it'll just keep on going. Right? So in other words, all of these, all conditions are mutually exclusive. Exactly one and only one will execute. Right? And moreover, the first one that evaluates to true is the one that gets executed. Okay? You can generalize this to as many conditions as you want. You can generalize this to any number of conditions. Right? If I wanted to have, say, 4 conditions, right? You can have something that looks kind of like this. Condition 1, condition 2, condition 3, condition 4, and an else statement. Right? Note that the else block is always always optional. Right? All you have to do to realize that it's optional is come up here to the if-else block. Right? What if I took off this else part? What would I have? Just an if statement. Right? It executes or it doesn't. Right? And the same thing with an if-else statement here. If I took off this one, right, then it's the same thing. It just doesn't have an else condition at the end. Right? Yeah. A catch would be for error handling. You're probably thinking of a switch, right? Like something like this. So int x, right, is equal to 10 or something. Here, let me do it like this. Right, there we go. And you do a switch on x, something like this, and then you would have case 10, right? Do something, right? Break. And if it's not the case that it's 10, it's, I don't know, 20. Then do something, break, right? And then finally default, something, do something, break, right? You'll probably read about this in Xi books. I'm not going to cover it because switch statements are just neutered if-else-if statements. If switch statements in C, at least, will only ever operate on integers and characters, because characters are integers. But it doesn't allow you to do, say, ranges. It only has discrete cases here. If you were doing some finite state control, you EE folks eventually, or you're doing some sort of, I don't know, a finite state machine, you probably really want to use a switch statement. But in general programming, you want to tend to stay away from it because it is very, very brittle. If you forget a break statement in there, then it happens to have fall through, and then it'll execute do something and do something, right? So it's very, very brittle, and that's why I don't generally cover it. But you'll see it in Xi books, and you'll see it elsewhere. Yeah? No, there are no exceptions in C. C++ has exceptions, and that's error handling. Java will have exceptions. C# has exceptions, but C does not have exceptions. Instead, you do what's called defensive programming and returning error codes. We'll look at that after the first exam. Other questions? No? Okay. So there is the basically all the conditions that we'll look at here. Again, style tips. The opening curly bracket is placed in the same line as the condition or keyword, right? The closing curly bracket is aligned vertically. And generally, white space, you want to indent things just because, like you've got lists. If you've got a list, a bullet-pointed list, and then you've got a sublist or a sublist, you indent everything, and then you indent them all at the same level. Right? Just get into that habit now. And if your indentations are tabs or 4 spaces or 3 spaces or 2 spaces or something, doesn't matter as long as you're consistent about it. Okay? All right. So we have already looked at a couple of examples, but now let's dive deeper into those numerical comparisons. Numerical comparison operators. Right, there we go. You can compare two numerical values, variables, literals, or entire expressions, right? Or a mixture of them using, here's our first one. If I write the Langle, we call that left angle bracket, right? So short, we call it Langle, but you always call it what? Because you have your math hats on right now. Less than, right? In fact, this is strictly less than. Right? Because you don't have this nice formatted LaTeX value on your keyboard, right? Neither do you have this one. Right? Less than or equal to. Do you see that on your QWERTY keyboard? No. So you have to use a combination, right, of less than or equal to. And note that it is read like that. Less than or equal to. So we have a less than sign and then an equal sign, right? This is less than or equal to. Yeah, go ahead.
I'm assuming if you do the other way around, it'll just...
Yeah, it doesn't... Good question. Some languages use that as a right arrow, like a mapping go from A to B. C is not one of them. C, what would happen here? C would die out on that. It would not allow you to compile, I'm sure. All right? Yeah, don't do that. Well, you can go ahead and reverse those two. What's this one? This one is strictly greater than. And if you use a combination of strictly greater than or equal to, or greater than or equal to, greater than or equal to. Now there's where the question comes in. What if you did like this? Something like that. Come on. There. That's definitely an arrow, right? A right arrow. But no, don't do that. And as we've already seen, the equal sign is already taken up. It's being used as the assignment operator. So how do we do a strictly equal? Two equal signs, right? And this is equality testing. Right? You can negate that if it's not equal to. And you don't have this symbol on your QWERTY keyboard either, not equal to, right? So what symbol do you use that's kind of looks like that? A combination of the exclamation point along with an equal sign, right? This is not equal to, right? Inequality. Right? All operators operate on two operands, right? Things, the left-hand side and the right-hand side. Right? You cannot use a combination of three things, okay? We'll look at that. Well, I mean, you can, but then you get into pitfalls and things that you don't intend to happen. And we'll look at a couple of those later on. Yeah?
Why is the percentage sign required to percentage signs?
Because that's formatting, right? You're talking about printf there, right? And percent %f. Whenever it sees a percent, it assumes, oh, that must be a placeholder. So what's the next character? Oh, it's an F. That means that you mean to format a floating point number. Oh, it's a D. You want to format an integer, right? And it just has that expectation. But if it sees, well, what if you want to print a percentage sign? Well, it sees a percentage sign and then it sees, oh, another percentage sign. So that must mean that you want to print that percentage sign out. That's called escaping. If you want certain characters, for example, an n-line character, that backslash before the n, that's an escape. It's not actually a backslash. If you wanted to print a backslash, what do you think you would do? Backslash, backslash, right? So we've never had cause to print a backslash, but if you ever need to, two of them, right? And then that gets in. Then you can get into backslash hell because if you ever want to use a regular expression, you need to use a bunch of backslashes. But what do you need to do? You need to escape them. So if you actually want two backslashes, you need to have four, right? And if you want, and then it gets, then you're in backslash hell because you've got so many of them. Right? And do I have the right number or not? Right? All right. So all values must be numerical. Right? Operands are going to be literals, right? Literals, like actual numbers. Right? Variables, right? Or expressions. Right? Let's come over here and just simplify it a little bit here. I'm going to simplify it by just simply creating that variable a there. Int b is equal to 20. Int c is equal to 30, let's say. Right? Here's our first if statement that we saw before. Right? You can compare a variable on the left-hand side to a literal, an actual value, hard-coded value on the right-hand side. Right? So you can compare a variable to a literal value. Right? And you can do stuff. Printf a is 10. Right? You can compare a variable to a variable. So if a has the same value as b, right? Printf a and b are equal. Right? Is that going to be true or false there? False. Why? 10 and 20, are those equal? Nope. Printf a and b are not equal. There we go. So I can use it in a combination of if-else statements here. Right? Let's go ahead and compile that and make sure that I'm doing everything correct. A is indeed 10, and A and B are not equal. Right? You can have a combination. If A is, or let's say A plus B is equal to C. Printf, hello. Right? Is that going to be true or false? True. Why? A plus B, 10 plus 20 is 30. Is that equal to 30? Yes. Right? So in other words, you can compare an expression and a variable. Or you can compare, you have all sorts of, you mix and match all of these things. For example, if A plus B minus C is that equal to 103, right? Etc. Dot, dot, dot. Right. So you can have entire expressions on either left hand or right hand side. What you should never do is if, I don't know, A is equal to A. Will that compile? That'll compile. Printf. A is indeed A. Right. There we go. It's going to compile. It's going to run. Is A equal to itself? Yep. A is indeed A. Right? Should you do something like that, though? No. Why? There's no purpose, right? That's always going to be true. What do we call something that's always true? Anybody who's any of the sort of logic classes? What a constant? Okay, it's kind of like a constant. In the context of logic, it is a tautology, right? If you've ever seen this word before, tautology, right? Something that is always true. If you've never seen that word, forget that I said it, right? We're not going to use it. You should never do this because, why? Because it is always true. If you want to print this statement, just print this statement. Get rid of the cruft, right? Don't make that kind of statement. Also, if 10 is equal to 10, right? Not good. Do not do this, right? And another one. Also, if 10 is equal to 20, right? Will this ever execute? Is 10 ever equal to 20? Nope. So no, this is called dead code, right? The code inside this block will never execute because 10 will never be equal to 20. I'm curious whether or not the compiler will even catch that. At this level, no. If I turn on all warnings, there we go. Self-comparison always evaluates to true. It's a warning. Are you sure you want to do that? That's kind of stupid. Right? Unfortunately, it didn't warn me about either one of these. I don't know why. But it definitely warned me about this one. Maybe it thought that, no, these are so self-evidently stupid that I'm not even going to bother looking at them. Right? What the hell are you doing? Right? Go ahead, do it. You're off in your own world. Go ahead and do what you're going to do. Right? That's what the compiler is probably thinking. You can, but probably should not, do the following. If 10 is equal to A, then printf A is 10. So now that's no different from what we started out with, right? It's no different than this one, logically. But read this. If 10 is equal to A, then print true. Does that sound right in English? It doesn't sound natural, at least, right? If you're going to compare a variable to a value, the variable should come first, right? It's unnatural, right? This seems unnatural. Natural, it is bad style, right? So don't do that, right? Yep, all right. What are some other things we could do? We could mix things around and check for even, odd, right? If A mod 2 is equal to, what will be the remainder if it's even? 0. So if it's even, then we'll print off A is even. End the line. And if it's not, then the only other possibility here is A is odd. Is 0 even or odd? It's even, right? Why? Because when you divide it by 2, what's the result? 0 divided by 2 is 0. So there's a remainder of 0, right? And so 0 is indeed even, by definition, both code-wise and numerically, right? Also, you cannot, or at least should not, do the following. If I've got, say, if apple is less than banana, right? There we go. Printf apple comes before banana. Right? What am I trying to do there? I'm trying to compare strings, right? And if you're thinking about a dictionary, Which one of those things would come first? Apple. Okay. So let's find out. Let's get rid of the warnings so that we get a nice clean compiling. So does apple come before banana? Yeah, apple comes before banana. So you might get the misimpression that in fact it works. Right? Let me go ahead and move that. Okay, darn it. Darn you. It's proving me to be a liar, right? Let me go ahead and change it around though. All right, so here, I'll put in the notes here. Seems like it works, but dot, dot, dot. Let me go ahead and switch those around. Let's go with orange, and then apple. Give me another fruit. Pear. Okay. Oh, no, that's true too. Give me a fruit that begins with a letter before O. Lemon. No. Okay. There we go. Is lemon a fruit? I think so. Yeah. All right. So it is orange. Oh, and I need to do this. Orange comes before lemon. Well, now think about the dictionary. Is that true? No. But orange comes before lemon, right? Yeah. It's just well. Technically, yes, that's probably what's happening at the end of the day. But you cannot use any of these to compare strings, right? Here's another example. If apple is not equal, or is equal to apple, there we go. Those two things are equal, right? Printf equal. But, in fact, we're wrong. Else, printf, this does not work. I am 90% sure that this does not work will end up getting printed. Oh, no, they are. Darn it. I know how to force it, though. Char star A equals apple. There we go. And I will compare A. Oh, you know what? I already used A, so I'll use capital A. There we go. There, nope, they are equal. Darn it. It's optimizing away. What if I did no optimization? Optimization level 0. Oops, no, GCC, optimization level 0. Okay, darn it. I'm not able to force it. All right, certainly we've seen it, though, already here. Orange does not come before lemon. What these are actually doing are comparing the memory addresses where these strings are actually being stored. And just because orange is loaded up in memory before lemon gets loaded up in memory, it has no bearing on whether or not O comes before L or L comes before O. So in other words, the takeaway here is that you cannot use these for strings. You cannot use the numerical operators for strings. Right? Instead, you need something more sophisticated that we'll get to when we have need for doing so when we get to strings. Okay? Only numbers or expressions or variables that are numbers. Okay? I'm going to go ahead and put this all into the notes, and you'll have your own copy. There we go. All right, other pitfalls. Pitfalls. Right. Mistakes, basically. You cannot use the numerical operators for strings, right, to compare strings. In fact, this is true of most languages. Only dynamic languages, like say, if you've had any Python, you can do that. If you've had PHP, you can do that. If you've had JavaScript, you can do that. Not necessarily that you should do that in any of those languages, but in any statically typed language, C, C++, C#, Java, right? Objective-C, whatever. You cannot use generally these numerical operators for strings. You may get away with it, but you'll, as far as it'll compile, but it will not give you the results that you expect. Okay. Other pitfalls. Let me see. Let's just jump over here to. There we go. Consider the following. Numerical. There we go. So what am I trying to do there? I'm trying to do a range, right? Does A come between 0 and 10, inclusive on both ends? If it's 0, then I want to print out hello. If it's 10, I want to print out hello. If it's 5, right in the middle, I want to print out hello. But if it's anything greater than 10 or less than 10, or less than 0, excuse me, then I don't want it to print out hello. Right? Let's take this code and see if it works. Right? Oops. There we go. And of course, I'll need A here. Well, let's test it for, I don't know, 5. Right? And let's print this out. What's it going to print? What should it print, I should say? Hello, because 5 is between 0 and 10. Okay. Well, let's go ahead and test one of those edge cases where it's actually 0. Is it going to work? Let's find out.
Yes.
Hello. Okay. Let's test the other edge case there. 10. All right. Still works. Ship it. I'm confident that it works.
What if we do?
All right. So yeah, give me another. Fuzz it. Right. Try to break it like you did in your lab on Tuesday with the with the birthday stuff.
Yeah, give me like a decimal.
Okay. You couldn't do that because it's an integer, so it'll just end up with integer truncation.
Higher than 10.
Higher than 10? All right. Let's try that. Ah, did it work? It didn't work as we intended to. It worked because it ran, right? And it did exactly what it was told to do. Computers are dumb. If you tell it to do something, even if you tell it to do something wrong, it'll do that wrong thing. Yeah.
So basically it's a code reading, so 0 is less than or equal to 15, so it goes, okay, that's
It goes left to right. We'll talk about that here in a second. Let's try one more thing, right? Negative 15. What should it do? It should not print anything, right? What does it do? It prints hello. This is a tautology. No matter what, it's going to print hello. The reason being is you read it left to right. Remember that you can only use these things on two things, a left-hand side and a right-hand side. And so when it ends up being evaluated, it evaluates this thing right here. 0 is less than or equal to A. Well, let's go back to one that we knew was wrong. Right? There we go, 15. All right? Is 0 less than or equal to 15? Yes, true. Now, here's something that we'll cover here in a bit, but true generally is 1. Right? 0 is false, true is 1. That's how it does it internally. And so because it evaluates to true, it gets replaced with, say, 1. Now, is 1 less than or equal to 10? Yep. So what ends up happening? Hello gets printed. Let's do that again. What if it's negative 15? Is 0 less than or equal to negative 15? Nope. So it evaluates to false, 0. Now is 0 less than or equal to 10? Yes. Right? So no matter what, if it goes 0 or if it goes 1, we end up with a true statement. Right? And that's why you cannot combine more than one of these things. Right? What would be the way that I would solve this? I would have to use a compound version of this. We'll talk about this in a moment, but I will use an ampersand ampersand for a conjunction, an and. Is A less than or is A greater than or equal to 0? And is A less than or equal to 10? That's the solution. But, so, the above will always evaluate to true, reasons given, because it evaluates the first inequality, right? And then defaults to either 0 or 1, right? Instead, use what I gave you, and we'll talk about conjunctions here in a moment. Here's another pitfall. Consider the following code. Right. There we go. So, A is equal to 5, and then I do something with it, right? Let me go ahead and copy this and find out what happens here. Hopefully you can immediately see what the issue is if you have very good eyes. Right. Printf, A is 10. There we go. Compile this. Is A in fact 10? No, but it tells us it is. All right. So what was the problem? Yeah. Missing an equal sign, right? This is an assignment operator. So now, understanding that it's an assignment operator, let's see how it failed, right? A is, I'm not asking the question, is A equal to 10 here, right? I'm asking the question, or what I'm doing is I'm giving a directive of assign the value 10 to A, which ends up being evaluated as 10. 10 is true. 0 is false, 1 is true, but it turns out that everything else that's not 0 is true as well. 10 ends up being true, and we end up executing this statement right here. So, how do I not get myself into this kind of predicament? Come on. GCC. Here's a preview of what I'm going to show you later on. I'm going to turn on all the warnings. Right? Before, when I compiled this just normally, right, it was okay with it. Right? But if I compile it with all the warnings turned on, it'll finally say something about this. Wait a second. The parentheses around there suggest that you are trying to treat this as a truth value, and in fact, it's not a truth value. It's an assignment operator. Are you sure you meant to do this? Right? By turning on all warnings, I'm getting this warning now, and maybe I need to re-examine my code here. Right? Again, the issue here is that the mistake is using one equal sign. This is an assignment operator instead of equals equals, right? Using the W all, or the hyphen W all, it's the wall flag, but it's the capital W stands for warning, and then the ALL, all of them. Tell me about everything that could possibly go wrong here. Will help you to see these mistakes. And we'll re-examine this later on when we talk about linters. Here's the final pitfall, and then we'll go back to some more material here. Consider that code. Yeah, go ahead.
On the last one,
Okay.
if you were to print A, would it still equal 5, or would it?
A good question. Actually, it is %d because it's an integer, and let's print it out. All right, still a warning here. So what do you think the value is going to be? 10, right? Actually, it is 10. Why? Because you set it to 10 right there, right? Before you printed it out. Okay? What about that one, though? Again, if you've got some good eyes there, you can maybe tell what the issue is. Yeah, the extra semicolon. That doesn't look right. So what's going on here? Yeah, go ahead.
I was just curious, is there some exclusive or
That's that caret. Yeah. Another exclusive OR operator would just be the not equals, right? Because 0, 0, right? No, equals, right? Not equals. Yeah, that's the exclusive OR operator, right? False and true, true and false would be both be true, and then 0, 0, 1, 1. That's assuming that you only ever use zeros and ones, though, right? But this is the bitwise exclusive OR operator. Right? All right, there we go. So I fixed the equals equals sign there. Who said that it was what was wrong? That extra little semicolon there. So let's find out what the behavior is here first of all. Right? Oh, hey, it warned me about it. If I turned on all the warnings, it's saying, wait a second. This statement, but the latter is misleadingly indented as if it were guarded by the if statement. So it's a little bit cryptic. It's using jargon to tell you that there's something wrong here, but at least it's alerting you to the fact that, wait a second, there's something wrong around here. Right? And that allows you to re-examine, oh, that semicolon shouldn't be there. But it's just a warning. In fact, that was just a note. Let's find out what actually happens here. A is 10. Is it? No, it's 5. Right? I didn't assign it the value of 10 because this is two equal signs now. So let's walk through this and understand what's going on. We check. If A is equal to 10, then do the next executable statement. What's the next executable statement on line 10? Nothing with a semicolon. Remember, semicolons are periods. Do nothing is an executable statement. Just don't do anything, period. Right? You can write that in English. You can also write that in code. So what ends up happening is, regardless of whether or not A is 10 or not, you end up doing nothing. Literally, you do nothing right here. And then it goes on with the regular control flow. And since this block is no longer bound to the if statement, it gets executed no matter what the value of A is. Right? So back that all up. What's the solution? Write good code. Failing that, make sure that you're using the WALL flag here so that when you write bad code, the compiler will help you and check that out for you. Right? Okay. All right. So those are some pitfalls to consider as you start writing your own executable or your own conditional statements here. There was our demo. General negation, other operators. Let's label it that. Other operators. Right? So there's the general negation operator. Right? That any statement can be negated using the exclamation point, right? So for example, you could say, is it not the case that A is greater than B? Now, as long as you put in parentheses there, because if you didn't have the parentheses here, it would end up negating A, and I wonder what that means. We'll talk about that later. But should you write something like that, right? This will be true, it will be flipped, right? It is equivalent to, how could I rewrite that so it's a little bit simpler? A is strictly greater than B. What's the negation of that? What's the opposite of that? Less than? Strictly less than? Or equal to, right? It is equivalent to A is less than or equal to B, right? So why don't you just write it that way? Right? Let me go ahead and give myself some more room here so that it goes on one line. There we go. All right. Always write simpler code, okay? This is better, right? Why? Better. Keep it simple, stupid, right? Keep the code simpler. Write your conditions as readable and as simple as possible, right? So that it's easier to understand, easier to maintain. Right? Other operators, well, this isn't an operator, but there's a Boolean variables, right? So by default, C does not have Boolean variables. That is variables that hold the values true and or false, right? Instead, you use numbers, right? That 0 is false and anything else, right? 1, 2, 42, -3, 2.5, -2.1, right, are all true. Right? It has to be that way because when you negate something, it can only be true or false. If it was just 0 and 1 and you negated, say, 10, that becomes 0. Right? If you negate that, it could become anything else. And that's because of the history of C. Well, we don't need a Boolean variable. We'll just go ahead and use numbers for it. Right? And it's a good idea to stick with zeros and ones, but you need to understand that 0 is false. Anything else is true in C. Okay? So you do have to be careful about that. Only 0 is false, and only 0 is false. Now 0.0 is also false, right? But that's just it's 0 by another name. Right? So how could we exploit this? Well, we could include an integer, is student. Right? Now we can't set it equal to true. Right? You are a student. You can't set it equal to false because those keywords are not built into C by default. So if I wanted to say that they are a student so that they get a discount, then what would I use for true and false? 1 or 0, right? False, true. I could be weird about it and I could say they're equal to 42, right? And that is true still, right? Don't do that. Don't be weird. Just go ahead and go with 0 and 1, right? And then you can write code like this. If is student. Now you could ask if it's true, right? Well, we can't do that because there is no true keyword here. So that's not going to cut it. If it's equal to 1, right? Then printf, you get a, I don't know, 10% discount. Remind me, what am I going to have to do to get that percent sign to actually print?
10%.
Percent. There we go. Good. So if is student, they get a discount, right? I'll go ahead and run this. They are a student, right? Because I set it to 1. True. Right? You get a 10% discount. A 10%, I should say, discount. Otherwise, you just get a 10%. You get a paper with 10 written on it. All right? But what else is true? 42 is true if you want to be weird about it. Are they going to get their discount? No. Why? Because I hard-coded it to only check for 1 true value. 1. They're not going to get their discount. Don't write code like this when you're using them as Boolean variables. Right? It's messy. Right? Is true. That's all you need. It's either true or false. Right? And you don't set it equal to true. You don't compare it to, is it equal to 1? Is it not equal to 0? Is it equal to 0? Right? You just use the variable, period. And that's how you use Boolean variables. Yeah. You could, but then negative 42 is also true, right? So you're going to have to write a lot of code to catch all the possibilities, right? That it's less than 0 or that it's greater than 0, and we haven't gotten there yet. Right? Now, if I just use this, 42, if you wanted to be weird about it, yay, they still get their discount. The only way that they don't get their discount is if it's false. They are not a student. Right? 42 will work, negative 42 will work, 1 will work, right? 0 will work. So when you're writing Boolean variables, write it like this. Again, keep it simple. Right? This is more complicated. Right? This is more complicated and it's wrong. Right? So keep it simple. There we go. So when writing statements with Boolean variables, keep it simple. Use the variable, not comparisons. Right? And I'll put that code that we wrote right there. Okay? There. You can also, alternatively, bring in a library to help you out. stdbool.h. Right? Yeah, go ahead.
So is that if statement saying that it is valid, that it's true?
If it has a non-zero value, it'll evaluate to true. If it has a 0 value, then it'll evaluate to false.
So like 28 is
Sorry, what?
you can put like 28 if it's student and it
Yep.
will
28. Just like 42. 28. I could put 0.5, but then it would get truncated and end up being 0. But there, you can still get a discount. Now, what would this look like if I brought in a library to do it? Include stdbool.h instead. Well, what does stdbool stand for? Standard Boolean library, right? And the way that you can use this is now you don't have to use an integer. Now you can actually use a Boolean variable, bool, right? You can still assign it a numerical value, but if you're bringing in this library to do some of the work for you, what it also offers is the keywords true and false. Right? So let's go ahead and make it true. There we go. Do they get their 10% discount? Yep, because they are a student. If it's false, do they get their 10% discount? No. So hockey season will start up. Do students still get free tickets?
Yeah.
Free tickets? That's a crime. Right? Faculty don't get free tickets. Right? All right, take a look at the actual library here. How does it define true and false? What are those called again? Macros, right? Preprocessor directives. All it's doing is assigning a human readable term to the value 1. All it's doing is assigning a human readable value to 0, right? And I don't even know if it, bool redefines bool, bool redefines bool, and that's it. Yep. It's not even saying what bool is. It defines bool as that, and then it redefines it as that. And oh, wow. I don't even see where it's actually defining what bool is. Ultimately, it's just going to be an integer, right? And that's it. Right? But it allows you to use human readable terms instead. Okay? I'm going to copy this entire thing because you need to bring in that library to do it. Again, C does not support that by default. Example. There we go. You have to bring in that standard Boolean library. And it's perfectly fine to do that if you want to. It's perfectly fine not to do that if you don't want to. Okay? Lastly, today at least, are more complex logical expressions. Right? You can use connectives to form more complex logical statements, right? Such as and or. Now that's not code. That's why I'm not scripting it as code. Those keywords are not supported in the C programming language. They're not supported in most programming languages. The only language that I know of that actually uses the keywords and or is Python, I think, right? The logical and operator is true if and only if both its operands are true. Here's the syntax. Because we don't use the keyword and, we use something that looks like it, ampersand, ampersand. Right? That's what ampersand means, right? That's just a fancy script for and. But you need to use two of them. If you use one of them, it has a similar but different meaning. It's a bitwise and operation. Right? Use two of them. For example, A is greater than 10 and B is less than 5. Each one of those is a statement with a separate truth value. Right? It's A is strictly greater than 10, B is strictly less than 5. I connect them together and make the entire expression true if and only if both of them are true. Right? It is true if the first is true, or and the second is true. Right? It is false if the first is false. It is false if the second is false. It is false if both are false. Second. So you can write this out as like a diagram. There are only 4 possibilities, right? You can think of it as 0, 1, 0, 1. That's how it's usually written. But think of it as a logical and, right? Question? No. Yeah, go ahead.
Yeah, can you like string more than two together? Like
Yeah.
when using an and?
Rethink what you're doing though, and then you'll need parentheses to make sure that it's all correct. You'll do that next week when you try to figure out the logic for a leap year. But yeah, you can do more. Right? Okay. Yeah, there we go. Questions on the and? Now, keep in mind that it is not the colloquial and. It's not the and that you use in everyday life. For example, if a mother told a child you can have cake, let's see. No, sorry. Hold that thought. I'll talk about that when we talk about the other one here, right? The logical or operator is true if at least one of its operands is true. Right? Here's the syntax for that. So if you've ever had a logic class, you might have seen the caret and the V, and those are the logical conjunction and disjunction. We don't use the keyword or here. Instead, we have to use these things. Do you remember what they were called? You use them in absolute value, remember? Where else do we use them? Bars, right? Vertical bars, the Sheffer strokes, right? They go by various names. You use 2 of them. On your keyboard, where are they?
Right next to the little forward sign.
They are right above the backslash, right? So if you type backslash, right? Right above that, the shift, that's your vertical bar there, right? And it's 2 of them, just like the ampersand. If you did one of them, that has a completely different meaning. It's a similar but different meaning. It's a bitwise or operation. Remember that you need 2 of them, just like the and, right? An example here would be A is greater than 10 or B is less than 5. Right? It is true if the first is true. Right? It is true if the second is true. It is true if both are true. Right? It is only false when both are false. Right? So there are the 4 possibilities. This one differs from the colloquial or, right? If somebody says you can have cake or ice cream, right? What do they actually mean? You can have cake or you can have ice cream, but not both, right? Hopefully they mean both, but that you can. But when somebody gives that kind of ultimatum, right, then they're not talking about the illogical or. They're talking about the exclusive or, one or the other, but not both. And also that would preclude a neither, so you have to eat your cake, you have to eat your ice cream, which doesn't make any sense either. Yeah?
So, is the not and not or, is that gonna be just exclamation point?
You can't do that. You can only negate one. So you'd have to put parentheses around the whole thing. And then you have De Morgan's law where things get flipped. We won't get that deep into it. Just rethink your logic. Right? Rethink what you're trying to do. So let me go ahead and grab this and let's do some exercise here. Right? So I will take that int a is equal to 10, int b is equal to 5. Let's start out with these. Right? If, there we go, printf true. Otherwise, and just to make sure that we're seeing, this clearly, I'll go ahead and print out false. What's it going to print in this case? Ooh, we've got a disagreement here. Let's take the first one first. Is a strictly greater than 10? False. And is b strictly less than 5? Also false. So both false. So that makes the entire thing false. Right? All right, fine. Let's go ahead and change it so that a is strictly greater than 15. What's it going to print now? Still false. Why? The first one is true now, right? 15 is strictly greater than 10. But is the second one true? Nope, it's still false. There we go. All right, fine. I'll set it equal to 4. Is 4 strictly less than 5? Yep. So now what will it print? True, because now finally both of them are true. Right? Before, both of them were false. Then the second, one or the other was false, and the entire thing ends up being false. Only in this example are they both true. Right? Let's go ahead and change this to 10 and 5 again. And let's change this to an or. Right? Is a strictly greater than 10? Nope, false. So now we have to check the other one. B is strictly less than 5? False. So what ends up getting printed here? False, because neither one of them is true. They're both false. Right? What if I change this to 15, making the first one true? So this is now true, but this is false. True or false is going to end up being true. Right? Let me change it so that it's back to 10. The first one is now false because 10 is not strictly greater than 10. But I'll make b smaller than 5, right? Making the second one true. So false or true is going to be true. All right. Now let's make them both true, 15 and 4. There we go. Right? What happens when they're both true? True. Right? It's not an ultimatum. It's not cake, ice cream, or one or the other, right? It is, well, both of them are true. It's still true. That's the logical or. Okay? I would think we went through all 4 possibilities there. Right? You can go through your own values, test them out, right? Throw a bunch of numbers in there, throw a bunch of expressions in there, and do some what's called coding kata. I think that's how it's pronounced. So does anybody do any martial arts? All right, do you know what a kata is? Or no, like, a Karate Kid, wax on, wax off, right? He forced him to do the same thing over and over and over again to train your muscle memory so that it is automatic, right? You just do it automatically, right? And that's I don't know anything about martial arts. I don't take martial arts. So, but I've heard that referred to as kata. And I didn't make this expression up, by the way. Somebody else made this up. And coding kata is exactly the same thing. Doing small exercises over and over and over again until your brain muscle memory remembers exactly how to do them. Right? And so that this becomes second nature. If you have exercise, 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 and you do it over and over and over again, you commit it to your muscle memory, and from then on, you just have to look at a piece of code and know exactly what it is, or what it means, and what it does. Right? So, go ahead and do these as an exercise for yourself some other time. Now, somebody asked about negation, right? If I put a negation in front of this entire thing, right, there we go. So it's not the case that A is greater than 10 or B is strictly less than 5. Does that sound all that natural? I couldn't follow that, right? If you went through the same exercises of all 4 possibilities again, you would probably confuse the hell out of yourself, right? Probably don't want to write, dirty code like this where reading it is difficult. Rethink your logic, rewrite it out on a piece of paper, and simplify it. In fact, when you get to circuit design, that's all circuit design is. Taking a logical statement and then redoing it so that it's a smaller circuit or a simpler circuit or a circuit that can use NAND gates because they're the cheapest to produce, right? And all those little tricks that come in handy of circuit minimization and stuff like that. Right? This is basically a circuit, right? We're asking this question: is this true? Is this true? Combine them, and there's a gate, right? It's an AND gate, an OR gate, right? A NAND gate. Have you done any circuits yet? Maybe some of you have, or you've seen some of it. Right? Kind of. All right.
You can't just It's have a a circuit circuit gate.
Plug and play. All right, yeah, you could. Well, you've got an AND gate here, right? You can just plug 2 things into it, and you can get an output. Right? All right. Any questions? Otherwise, we'll continue it there on Tuesday. Excuse me. Remember that Monday is a Labor Day, and it doesn't affect this course, except in your due dates. Reading 3 is now due on Tuesday. I'm not going to have it due on and Hack 2 is also due on Tuesday because of the Labor Day weekend.